Okay, here we go. The sum and differences angle theory. So I think I had to prove this in university. I'm not exactly sure. I remember the prof doing it, but I definitely had to go to Khan Academy or wherever I did. And we're going to propose the question in blue down below, big blue. What is sine of alpha plus beta? So off to the left, we see the angles alpha plus beta. And I know in big red, that would mean that is this height for a whole bunch of reasons that we're going to work through slowly. Well, no, excuse me. I'm not going to work through slowly. I'm going to try and see if I can prove it. So, no, I'm not. I'm just introducing it. Feel free to print it off. Ask your teacher to walk you through it if they have the time. It's very difficult. I'll probably ruin it. I never do it right. I really have to write a script for it first, and I haven't done that, so excuse me. But this is perfect math, and down below sets up for the first addition identity on our formula sheet. If you recognize that one, that's where it comes from, and that is where all the other manipulations of the proofs really kind of work through, and we're going to have to use this identity all the time. So now let's get on to some examples. Okay, simplify, expand, sum and differences. So I didn't get through the theory very well, but I just squared one of the formulas from your formula sheet and kind of spoke about how to get some information on whether or not you want to prove it or not. You don't have to, but it really helps understanding some of these things. So I'm going to do the question in the top left hand corner. Notice I've written the trig identity directly above it. So first of all, I'm going to write the question in black below it. Sine of x plus pi, and ask myself what's that equal to. Sine of x plus pi, and ask myself what's that equal to. So I have a definition, and I'm on the left-hand side, so have your formula sheets out and look in the addition identity section. And we have an identity for a left-hand side being a sine plus, and that's sine of a plus b is equal to sine a cos b plus the reverse, sine b cos a, or cos a sine b, whichever way you like. And that's an identity, so I'm going to put a big square around, rectangle around it as best as I possibly can. So now I can just follow the formula. So I can clearly see from the left that my x is a and that my pi is b, so I can substitute. So in for a, we'll say sine x cos, and in for b, we'll say pi plus the reverse, sine pi cos a being x. And I'll start off on the right with sine of pi, and I know that sine of pi is the y value of the unit circle, and the y value of the unit circle at pi is 0. So sine of pi is 0, therefore it's 0, therefore sine of pi times cos x is 0, and it's gone. And then I'll work on cos pi, and cos is the x value of the unit circle, and the x value of the unit circle at pi is 0, is negative 1, which makes this equal to negative 1, and sine x stays. So look at how we can simplify that. So sometimes we simplify something, sometimes we expand and simplify, sometimes we start from an expansion and go to a simplified form and then possibly work on it further. So let's take the next example off to the right. Cos 45, cos 30, I'm going to bring it down a line so I have room to write the formula directly above it. Cos 45, cos 30, plus sine 45, sine 30. And wonder what that equals to. Well, I can see from my formula sheet, I'm in the addition identity section, and I have a right-hand side of a cos. So I'm going to write the identity directly above it. Cos A cos B plus sine A, sine A, sine B equals. And that is a cos plus. And a cos plus is equal to, it's a cos, so it's a cos. And it's the opposite sign, so A minus B. So I can recognize off to the left that my A is 45 and my B is simply 30 in both patterns. So it's simply just equal to cos of 45 minus 30, which would also equal the cos of 15. So, sure, that's a little bit simplified. Maybe you'd want to expand cos of 15. Maybe you want to simplify. Excuse me, I wrote a formula down and I forgot to put a box around it. So you may be said to compress this into a single trigonometric identity or trigonometric function or whichever ratio. Or you might have to expand it to be a fraction. So that's what we're going to work on next. So I'm going to underline this one because I'm starting a new question. And let's say sine of pi over 12. Now, off to the right, I've shown the addition and subtraction of fractions with respect to radians. That allows you to get the correct subtraction of radians that will eventually work with the formula sheet. And it's just so difficult. I know that way off to the right, pi is equal to 180. Therefore, pi divided by 12 would be 180 divided by 12. What's in 180 divided by 12? 15 degrees. Therefore, this question is just the sine of 15 degrees. Now, I don't know why someone would do it differently. Possibly reasons, obviously reasons. But looking at the angle 15 in big red, we want to find an addition or subtraction of angles that makes that. And I know that, off to the right, 45 minus 30 is equal to 15 degrees. So I can substitute sine of 45 minus 30. And as teachers are going to do, they're going to say, okay, look at your formula sheet. Now, looking at my notes, I've written down the formula that you're going to be using off to the right. It's called a sine minus. But I'm just going to follow the English code below. Sine is the same sign, and it's sine, cos, sine. Cos is the opposite sign, and it's cos, sine, sine. So I'm simply going to have a sine 45, cos 30, same sign, switch it, sine 30, cos 45. I've run off the page. I'm going to shrink this a little bit so everyone can see it. And there it is, that expansion. So I know from the intro to trig, sine of 45 is 1 over root 2, special triangles, look it up. Cosine of 30 is the adjacent, and I know opposite of the 30 is the 1. So therefore, the adjacent is the root 3 over 2. Minus sine of 30, well, opposite of 30 is the 1 over the hypotenuse, 1 over 2. And cos of 45 is the same as sine of 45, 1 over root 2. Then I can combine these things. I have a lowest common denominator of 2 root 2, work it out. And on the top, I have root 3 minus 1. Again, work it out. I'm going to circle that answer. So, all throughout, you could rationalize. I just say to rationalize in my notes, but feel free to multiply the top and bottom by root 2. So now I'm going to talk about the box at the center, cos of negative 75. Well, negative 75 is just negative 45 minus 30. And negative 45 minus 30 means we're a cos minus. Disregard the negative in front of the 45. But we have a minus in between. Therefore, A is negative 45 and B is 30. So the expansion would be cos negative 45, cos 30, plus sine negative 45, cos 30. And there's all sorts of other stuff like or. Well, we have another definition from functions, from the function formulas down at the bottom, that cos of negative x is equal to cos x, because it's a horizontal reflection. And sine of negative x is equal to negative sine x, because a horizontal reflection is equal to a vertical reflection. And all sorts of other stuff. So you got a bunch more examples on this page down below of different ways to find additions of angles. An example with a reciprocal function like secant, where we have to do 1 over sine and do that expansion. A note at the top of the page that says tan theta equals sine theta of cos theta. So if your teacher's ever going to give you one that you have to use, that you don't get the formula sheet, the tan example is at the bottom of my formula sheet, then you have to do a sine expansion over a cos expansion. It's difficult. And there's a box at the bottom with a whole bunch of other angles. For example, sine of 255 from earlier trig intro is negative sine 105. Figure it out. Sine of 255 is also 360 minus 105. And we can expand that. And I actually went off to the right because I was running out of space here. But theoretically, we're always just using the English sentence at the bottom left-hand corner of the page. We're always going to be using a combination of special angles and quadrantal angles. And there's a few examples off to the right. 255 could be 180 plus 75. Or 180 plus 45 plus 70. Or 285 could be 180 plus 105, and 105 is 160 plus 45. All sorts of examples. On to the next section, double angles, where the sum identities came from, double angles, or vice versa.